Hey there, welcome to my project on building a better BLE lock. Bluetooth Low Energy, BLE for short, is a wireless personal network technology used in everything from home entertainment and automation to security to fitness and medical devices. Today, almost all Bluetooth-enabled smartphones support BLE. If you're wondering where the name came from, well, it came from this guy, King Harold Bluetooth Gormison from the 10th century, who apparently had some dental issues. In fact, the Bluetooth symbol we all know and love is a combination of his initials written in runes. Anyway, on to the fun stuff. As for hardware, we've got electric solenoid lock, just a regular Mega 2560 Arduino, and an Adafruit NRF 8001 BLE shield, which of course gives the Arduino its BLE capability. For this project, I want to be able to control a BLE lock with a smartphone app. First, the app connects to the Arduino. Then the Arduino creates a one-time PIN, encrypts it, and sends it to the app. The app decrypts the challenge and sends back the PIN as a response. Here's the Arduino code that makes it all happen. I won't go through and explain it line by line as I don't want anyone falling asleep while watching this, but the source code is available on GitHub. See the YouTube description for the link. Now, let's compile and upload it to the Arduino. Let's open the serial monitor so we can see what's going on the back end. Okay, it's up and running. We have the BLE shield advertising that it's available. Next, we fire up the app to connect.
Connected. Unlocked.
Now it should open the lock for 5 seconds, then relock it. To prevent somebody from running a replay attack on the lock, if an invalid response has been received, the system simply ignores any further input from the outside for the remainder of the connection. I ran into one big problem during this project. I picked up an Adafruit BLE sniffer in the hopes that I could use it to demonstrate sniffing a basic BLE connection and using my findings with a tool like GATAcker to launch a replay attack. Then show that a standard replay attack wouldn't work with a challenge and response system like this. But unfortunately, for whatever reason, the only network traffic I could see with Wireshark for BLE was just the advertisements. I plan to investigate this further in the future, maybe with a more robust sniffer like the Ubertooth. If I were to continue building onto this project, there's a few additional features or functions that would polish it up a little. The first would be to lower the transmitting power of the NRF 8001 BLE shield. This would make it even harder to sniff, as it would further limit the distance the sniffer could be from the lock. This is possible with the shield, but the Arduino libraries I have access to at this time don't appear to have support for it. Another function I would have loved to have had would be for the ability for the Arduino to automatically disconnect from the session in the event of an invalid pin response, instead of just staying connected and ignoring all communication. One of the new things I've learned during this project was to do some Android smartphone app programming. Without any prior experience at all, I was able to produce the custom app I used to control the lock within just a few hours' time. This was all made possible by using MIT's fantastic App Inventor site and utility. It uses a graphical interface that lets programmers of all levels quickly design and implement whatever they can think of. It uses drag-and-drop visual objects to build the app front end, and a visual programming block editor to write the back-end logic. The language itself, strangely enough, has no official name, but is closely related to MIT Scratch. I highly recommend checking it out. I'll put a link to it in the video description. Well, that's all for now. See you in the next project.